Rothfutch method of mixed designing the aggregates or mixed proportioning of aggregates. Uh, this is one of the typical example of mixed proportioning of aggregates for DBM grade 2. Before going to that problem discussion, just uh, we'll discuss what exactly the Rothfutch method is, why we need to do the mixed proportioning. This is one of the graphical method of mixed proportioning of aggregates to get the required grade. Now, why we need to do this? Because for different layers of highway construction, the gradation values given by Moore is different, and it is not possible to get the same graded aggregates from quarries. From quarries, we'll get aggregates in different sizes, and it's our responsibility to mix the different sized aggregates in different proportion to achieve this required grade. So now I'm just discussing about how to mix the different sized aggregates to get this DBM grade 2. You can see this required gradation for DBM grade 2 is for 26.5 mm it need to be 100% passing, for 20 mm it need to be in between 91 to 100, 13.2 it need to be in between 56 to 80, same way for different per sizes, sieve sizes. Here I have taken four different group of aggregates: 20 mm, 10 mm, 6 mm and dust. These are different sieve sizes. As for 26.5 it is 100% passing, just I have neglected that in the sieve sizes. Here these are the different percentage passing values. This is obtained after sieve analysis of these different group of aggregates individually. Now, how to plot the graph? How to plot the graph? This is a graph of Rothfutch method. So you can see here. Here the important thing is to fixing of x and y axis. This is y axis, this is x axis. How to fix this? Take 10 units in y axis and 15 units in x axis and join these two extreme ends, and this will give you the gradation line. This is gradation line because if you join if you plot the midpoints of different midpoints of this required gradation for corresponding to sieve sizes, then it is treated that you will get it in this straight line only. Hence this helps to fix the x-axis. I will discuss about how to fix the x-axis. Now before that we'll fix the y-axis. Each unit is treated as 10% passing, and then as we have taken 10 units, so it varies from 0 to 100% passing. Y-axis is percentage passing and x-axis is sieve size. Now the next step is to fix the x-axis. So using the gradation line and using these percentage passing values, we can fix the x-axis. As from the gradation table we know that to 100% passing is there for 26.5 mm sieve. That's why directly we will take this origin as 26.5. Then for 20 mm sieve it is in between 91 to 100. Take the midpoint and then project it. You will get the x-axis point, that is for 20 mm. In the same way for 13.2 mm, that midpoint of that required gradation is 68, projected to get the x-axis as 13.2. So the same way fix the point for 4.75, 2.36, 300 micron and 75 micron points. The next step is to plot these curves: 20 mm curve, 10 mm curve, 6 mm curve and dust for the given for the calculated percentage passing values. See here this is 20 mm curve, this is 10 mm curve, this is 6 mm curve and last is dust curve. The next point is to draw a balancing line. A balancing line is one which divides a curve into equal parts with the least size in between the balancing line and a curve. So we have already discussed about that balancing line, so just draw the balancing line for all these curves. The last step is to join the bottom of first balancing line to the top of next balancing line. Just join these two lines, and that line cuts the gradation line at some point. So this project that to y-axis and this gives the percentage of this curve or this aggregate to be mixed to get the required grade. It means this is 20 aggregates to be mixed at a proportion of 31 percentages, 31 percentage. And then similarly draw a line connecting the bottom of this balancing line to the top of next balancing line. Even that will cut at some point. Project it, and this will give you 40 percentage. It means 40 percentage of 10 need to be mixed. In the same way, calculate for 6 it is 25 percentage, and remaining is 4 percentage of dust. So at the end of this uh, graphical presentation, you will get the percentage of different sized aggregates to be mixed to get the required grade. This is what the conclusion. As per the required gradation for DBM grade 2 as shown in the table, and as based on Rothfutch method of mixed proportion graphical method, for 20 10 6 and dust, the percentage of aggregates need to be mixed are 31, 40, 25 and 4 respectively. This is how we can conduct, or we can design the aggregate mix to get the required grade using Rothfutch method. Thank you.